Good job. I will have to make this up to you at the end somehow. I owe you something, a coffee or something.
All right, you're good.
All right. I appreciate your help. So partial fractions. So if I had an integral that looked like this, let's think about what I might do. Starting from that perspective on this that maybe I don't know. Like in real life, you got an integral, you don't know how to do it. So I could maybe try some substitution. It's a fraction, right? And I told you that thing about fractions. It's like, hey, the fraction with no parentheses in the bottom. I could let u be x squared minus 4, and then du is 2x dx. And I see that I'm kind of screwed because I need an x in there for this to work out. So that's not substitution. And then parts. Parts sounds horrible, right? Like, what are my parts going to be? I'm going to let u be this monstrosity, and then dv is dx, you know, maybe some weird shit like that. Think about what the derivative of this is going to be. It ain't pretty, right? It's not getting better. Life is not getting better. The derivative of this thing would be, I think, this, and then it just gets worse from there. And then this x comes in here, and you know what, actually that might work, but let's not go that way. I was actually thinking that could work. I think that the VDU integral is actually doable because you do get an x. So that's kind of cool. So this could work. But yeah, I'm gonna show you another way. So maybe not the best example that like could be done by other means. But this thing inside here is a fraction that actually can be factored. And I'm gonna pull the 3 out in front. And notice I can factor that as the difference of 2 squares. Does that sound cool to everybody, like that basic idea? Yeah. All right, so here's the kind of the hallmark here. I've got a fraction of polynomials. So I'm going to try, that are factorable, and the denominator is factorable. These are the key points. Fraction of polynomials, denominator factorable. We can try this new method. And the method title is partial fractions. So this is all about thinking, how do you actually produce a fraction like that from adding fractions together? So as a reverse of this process, we do a little scratch work for this method. So this fraction, I'm just going to take 1 over x minus 2x plus 2, and realize that could have come from the sum of 2 simpler fractions. So let's think about this for a minute. And I'm going to put an a and a b on top. These are numbers I don't know yet. But if I asked you to add these 2 fractions together, what would be the first step? So let's just say, what if I asked you to do this? How would you do that? Just like kind of as a separate, yes, Scotty?
Find a common denominator.
Get a common denominator, yeah, beautiful. So like if you had this, you would say, get a common denominator, which is that times that. And so you'd have to multiply this one by x plus 2 over x plus 2. And then this one I'd have to multiply by x minus 2 over x minus 2. And then I'd do all the stuff. So let's see, what the bottom, we get common denominator, like Scotty was recommending. Then this would be 3x plus 6 plus 5x minus 10. And then that would all simplify to 8x minus 4 over x plus 2, x minus 2. So when I see this fraction, I see a fraction like this, the crux of this method is that that could have been written as the sum of 2 other fractions, these original 2. So we're going to deconstruct the fraction that we're given. So that's what this method is all about. So our goal is to deconstruct, which is just a fun word to say. It always feels like you're doing something super fancy, right? If you go to a restaurant and you get something deconstructed, you are going to pay out the ass for that meal. I can guarantee you that. I want a deconstructed grilled cheese and tomato soup. You're not going to get much food, and it's going to cost a lot. That's what's going to happen. This is not that. You're going to get a lot for this. You get a lot for your money with this. So we deconstruct the fraction into a sum of simpler fractions. So this is the setup here. The setup. And we're going to talk about a bunch of different setups. I'm going to keep this rolling on Friday. We're not going to do all the possibilities today because it can get pretty involved. But I create a fraction for each one of the denominator parts. And then I've got to find A and B. So the setup is write that. Then the next step is to now find A and B. There's lots of ways to do this. I'm going to show you what I consider the easiest route. Take that equation, let's call it star, and flatten it. So flatten star. And what I mean is get rid of the fractions. So multiply through by the denominator on the left side. So multiply by the original denominator, both sides. So when I do that, I'm going to get on the left 1, I get the numerator. On the right, look at what I'm going to get. I'm going to multiply this thing by x minus 2 times x plus 2. Notice that the x minus 2's will cancel, and I'll be left with that. And then when I multiply the denominator by that b over x plus 2, the x plus 2's cancel, and I'm just left with x minus 2. Let me stop there and find out if this is going well. I feel like I have a cup of tea somewhere, but do you see it anywhere? It's right here. Oh, cool. Thank you. That's good. I hope I didn't take it into the bathroom. It's like I'm never going to drink out of that cup again if that thing goes into the bathroom. Nah, that's not true. But I'd probably wash it first. Any questions on getting to here? Good? Okay, so now, this has to be true. There's 2 ways we can go here right now. Here's the easiest. This must be true for every value of x. So I'm going to plug in good x values. I'm going to put in that in quotes. Good x values make things 0 or 1. But for this, I'm going to pick x equals negative 2 to kill this off, and I'm going to pick x equals positive 2 to kill this. So let's let x equal negative 2. And then plug that into this equation and get 1 equals a times 0, and I'll write this out the first couple times, plus negative 4 times b. And look, I know what b is now. B must be negative 1/4. And then let x equal positive 2. And when you do that, this piece dies. So you get 1 equals 4a. So a is a positive 4th. And I've done it. So now I'm going to rewrite this whole problem. I now know that, bless you, that 1 over x minus 2 times x plus 2 is equal to 1/4 of this minus 1/4. I'm putting the minus out front here. Minus 1/4 of this. Now, I've got 2 way simpler problems. I don't know, I feel like that was like a horse imitation or something like that. Kind of a neigh. Mr. Ed. Does anybody even know who Mr. Ed is? Yeah, it's like Mr. Ed. Whoa. Whoa. That's how a horse talks when they talk. Okay, so nobody wants to hear that. So integral. So I'm going to rewrite this as 1/4 over x minus 2 minus 1/4 over x plus 2. Each one of those is cake. finish this for me real quick, please? What is the answer? Or you can stay. You can do as you see fit. So hopefully you've seen these are natural log forms. Got a fraction, let u be the denominator in both of them. So like for that first one, let's just talk about this and then you can see the other one easily. Let's let u equal x minus 2, because that now the fraction game is going to work that I always recommend. Du is dx. This literally just becomes this, and that becomes this, and that returns to this. And the 1/4 are out in front. You can pull, hell, you can pull the whole 3/4 out in front if you like. That makes things easy. Get that. Let me know. Yeah, sound good? If not sound good, let me know. Yeah, you're good, sorry. Oh, it's okay, cool. Awesome, so let me just show you one thing I can do, log properties, because I like to sometimes do this, and you'll sometimes see an answer that you're like, how the hell did they get that? The difference of logs is the log of the quotient. So if I have log of something minus log of something else, that's the log of the quotient. Vice versa, I can go from here to here. And then if I have a power out in front, so if I have c natural log of something, I can bring that up inside. So I could, if I was feeling, spicy that day, I could do that. And that would be okay too. You don't need to do that, at least for the time being. But there might be circumstances where you wanted to do that. Any questions on this? Yeah, oh yes, now you do have, yes.
Just about the log, what happens when x is -2?
Oh, so like worrying about this denominator? Yes, so what an awesome question. I like that you're worried about the domain and the defined values. So let's check it out. X could have never actually been 2 or -2 to begin with. So I really appreciate it. So just write down here, we would definitely, X can't equal plus or minus 2. But yeah, great question, good observation. Other comments or cool things to see? Let's try one together. Here's a fun one. I'm going to factor it for you. Let's do what we did, but let's add in a third factor. Luckily that's factor 1, because otherwise that could be a pain. How many fractions do we need now? 3. So you're going to need an A, a B, and a C on top. Give it a shot. And you end up feeling kind of powerful. You really just decimate these fractions. Do a little scratch to set up. careful when you flatten. Because only one thing is going to cancel each time. So be mindful of that. Yeah, so you need that equal one there for sure. Yeah, yeah. So I'm going to multiply through by all three of the ones. So when I do them on the left side, you see now? Okay, yeah. Yeah, yeah, okay, good. Doing good. If you're writing a lot, I know you're doing it right.
Right, so they are killing all of the line. That's everything. I thought about doing it.
Got it rocked out. Sorry. Oh, it's okay.
I'll just
No.
disassociate.
Oh, okay, sorry. That's all good. That's all good.
How does this with the like A over become flat?
Okay, cool. So take a look at this. Look at the original. I multiplied both sides by that denominator.
Yeah.
So the left side becomes just the 1. Do you see that? So I'm multiplying like across the top by it. Oh, sorry, it's okay. So if I multiply this thing by the thing that's in the bottom, I get a 1. But I also have to multiply the right side. So when I multiply, do you actually see what I'm saying?
Oh, because you're saying you have to multiply everything by both of those?
Yes.
And so that all just have to.
Correct.
Oh, okay.
And then when I do it over here,
And when you have the same denominator, you can just get rid of it.
yeah. Uh-huh.
Oh,
Yeah.
yeah, I see it.
Now you see it. Okay,
Yeah.
cool. What's your favorite Pink Floyd album?
Final cut.
Oh, wow.
Mm-hmm.
Wow.
I think it's underrated.
Nice. I'm a Dark Side of the Moon
It's
guy.
pretty good. They released the 50th anniversary album. It's like $300.
Yeah. Damn.
Not for me.
They're good, but
Yeah.
yeah.
I saw Red
Yeah.
Waters in September.
Wow. Oh, wow.
Yeah,
Have you, like, one of my other favorites is Piper at the Gates of Dawn.
it's a good one.
Yeah. Yeah, they were making interesting music.
Interesting.
Yeah. And then Umaguma. I mean,
Umaguma is just a monster of its own.
come on. I remember the first time I heard listen to Dark Side of the Moon. I was in the dorms at the University of Illinois. We had the windows blocked up with a fan in them. And it was an incredible time. For some reason, they never went around the outside of the dorm looking for all the windows that were blocked up with fans blowing out.
I'm an RA and it's just like, I don't wanna, you know, like, I can just, I did not see it.
Yeah, I did not
It's
see
not
it.
worth
Yeah,
it.
yeah. Does this look good for any questions on that flattening? Because if we ain't got that rolling, this isn't gonna work. And then you've got 3 special x values, right? And each time you pick one, you get one of the constants on top. So x equal 2. Just gotta figure out what term survives. That was a different time too. That's fans blowing out of the window were less legal than they are now, so it's a little scarier. Let's see.
It's still illegal to do that because something about this being like a federally funded campus.
Oh, yeah.
Yeah, we're not supposed to be cool about that.
Yeah, I guess
So
not.
I don't know.
Yeah, so it goes, so the legend goes, yeah. Not that I'm condoning it, just for the record video. Oh, no. See this time. Just be real careful here. Is this, how am I, did I screw up? Are we on the same page? Looks good? Those three constants?
So you
One-
only
yes.
plug it into whichever one you're trying to find?
Well, I plug it in, sometime, no, so let's be careful. I plug it into all of them, but I'm noting that the other two will die because of that. But that won't always be the case, Sophie. So like when I plug in 2, I'm not writing the others just because I see that there's gonna be a 0 there, but there won't
Oh.
always be necessarily.
Oh, okay, yeah.
So then, just rewrite my whole problem. As integral 1/12 x minus 2. You're gonna start recognizing these are all just natural logs, right? This is all just natural log stuff. So if I have integral of this, that's just the natural log of that. So it's a good thing to keep in mind because it's going to happen a lot with this process. And it makes us wizards. And there's no need to go any further. Because we've actually just done something really impressive. Yeah, exactly. Yeah, power. It's just power. Rush things in my head. Powerful mathematical. Any questions on this? No? Yes.
Is there any way to tell what the, I guess, numerators would be before doing the whole process, or?
No simple way with mathematics we have access to at this point. There are some ways, but they require complex analysis, which is like this class with imaginary numbers, which I'm teaching this fall, by the way. Calc 2 is the prereq. Come join me. You'd be surprised at how amazing it is, how beautiful. Let's do one more kind, and then we'll call it a day. I want to show you, if there are no questions, and I'm getting the sense that there aren't, because I do want to have time to talk about that web work, folks. So one last example, and so this one, notice here, everything we've done so far is distinct factors. When I factor the polynomial, there's no repeats. There's no like x minus squared cubed or anything like that. So let's talk really quickly about repeated factors. So if I was given, and let's forget about integrals. Let's just talk about a polynomial that we want to break apart. So let's say I've got x plus 1 squared times x minus 2. So I've got this thing here. And I want to figure out what this could possibly be as a sum of different fractions. The setup here is kind of the same with a little twist. So certainly an x plus 1 is going to be possible. Also, an x minus 2 is going to be possible. Now, notice how I'm leaving a little space. But for the ultimate, the most general situation, I don't know, I could have had this fraction in there as well. So what, I have a repeated factor, I account for every power of that factor from its given power down to its first power. So like if this were cubed, I'd also have another one in here. Let me show you real quick. So if I had this, then I would do, and it doesn't really matter what letters get associated with what. I would have something like that. So with these repeated factors, you want to account for every single power that occurs. Let's go back, because we don't want to do this one right now. But this is also going to answer Sophie's question from earlier about, am I just like plugging it into the things that matter? So let's do this. So this would be my setup. The setups look the same. There's something here I'm not talking about and I'm trying not to talk about till Friday, so this is good for now. Flatten. So now I flatten. Could you flatten it for me? Give it a shot. I'm going to get x plus 3 equals blah. Just to make sure it's all. To keep you all awake. Okay? Yes, we can.
Would C be x plus 1 cubed?
Oh, I changed it back to a square.
Yeah, but when you flatten it out, because it would be x plus 1 times, no, I'm thinking of it wrong.
It's okay, no, it's good. I'm glad you talk it through. Sometimes just you gotta like talk that stuff through. That's good, yes.
I still don't understand why there's a power on x plus 1.
Because so, let's say if I gave you these fractions to add up, let's do it like this. If I said do this math for me. And let's go one more. How would you do that?
Common denominators.
Common denominators, right? And what would be that common denominator you were shooting for?
Probably x minus 1 to the cube.
Yeah, exactly, right? Because this one I could multiply by x. Oh, shit. Sorry. I meant this. Sorry about that, Gabe. Yeah, but meant that.
Yeah.
But still, same answer, right?
Mm.
This is my least common denominator. So I'd have to multiply this one by x minus 1 squared over x minus 1 squared.
Okay.
This one would have to be by x minus 1 over x minus 1. But in the end, I would end up with a single fraction that just had this as its denominator. So what
Okay.
we're doing in backwards is acknowledging that if I have a fraction like this, these are all likely possible things that could have contributed to it. Does that make sense?
Yeah, that makes sense.
Awesome, cool. Any other questions on the, yes?
Why can't you just from the beginning break it like apart and just have it be like x plus 1 times x plus 1?
Oh, you mean like write it like this?
Yeah.
I mean, I could, but I would still have to account for the x plus 1 times the x plus 1. Just because they're the same, so it acts a little different than if they were like different terms.
Okay.
It just acts different in the algebra. I don't know how else to express it. Is that, yeah, thanks, yeah.
I guess I'm still trying to work around that then, because by that token, if you're trying to account for multiplying x plus 1 times x plus 1, why don't you also have to account for like x plus 1 times x minus 2? the same
Just
way.
because they are different. So it really comes down to the fact that this here, that if I have one of these, so check this out. If I had one of these and I wanted to know where it came from, could have been this, could have been this, could have been this, could have been all three combined. What if I tack in this? All of a sudden now I've got this. Well, I really only need one thing to contribute to that. So maybe there's some other, some number here. But notice that that one is totally handled by a single fraction of its own. This alone puts that into the denominator. Is that,
Yeah, that makes
yeah?
sense.
Okay, cool.
How do you solve for A? when you
Well,
get
there
to-
we go. Now, okay, cool. Part two. How about part one? These part one questions are, I'm getting scared because I'm afraid you're gonna ask something I can't answer, but I'm doing all right. Yeah, Voin. Okay, okay. And we'll practice more on Friday. I promise we will practice more. So now let's get to Abraham's question, but we have to flatten. We have flattened. So now I said that whole thing about picking special values. So now we're gonna pick values. Unfortunately, there's only two good values to pick, right? There's two really awesome ones that make things zero. You're looking to kill off these factors when possible. So when x equals 2, dead, get something. When x equals -1, dead. So let's see that. I don't think that's explaining why it's bad. So let's just do it. So I'm gonna let x equal 2 because I know that will kill off a bunch of stuff. So the left side becomes 5 because it's 2 plus 3 equals dead. 9c. Right, because you get 2 plus 1, 3, quantity squared is 9. So now I know C. Yay, get C right off the bat. Let's do it. C equals 5 9s, cool. So there'll be a 5 9s on top of that. And then we're gonna pick x equals -1. So now the left side becomes 2. And then I get, I'm at -1, so dead, not dead. I get -3b. So we now know b equals -2/3. Cool. So now Abraham's question is, but there's a, and we need a. So now we pick, there's a couple of ways to approach this. Pick any other value you want now. But you can do this wisely because we're going to pick one more value that will relate a, b, and c together, and since we know 2 of them, we've got the third. Let's be wise. Let's pick nice values. So I'm going to pick x equals -1. Oh no, I already did that. I'm going to pick x equals 0 because that shit's easy to plug in, right? 0, 1, -1, when you got them, go for it. So I'm going to let x equal 0. I could have let it be anything. 3 is not a bad one because it'll make that a 1 and that a 1. But when x equals 0, I've got 3 equals -2a minus 2b plus c. And now Abraham, now I got it. Because I'm going to plug these two in. So we're going to get, so plug c equals 5 9ths and b equals -2/3 into this. So we get -2a minus 2 times -2/3 plus 5 9ths. And then some fraction work, and it's okay. We just take a deep breath and be grateful we're doing math and not shoveling snow for Regis for free or something like that, or whatever. It's probably better to be doing math, right? Yeah, okay, cool, okay, all right, good. So then let's get these two together. Let's see, so that's 17 ninths. I just multiplied this one by 3/3. And then I'm gonna subtract the 17 ninths off, so I've got 27 ninths, which is 3, minus 17 ninths equals negative 2a. So 10 ninths equals negative 2a, and a is negative 5 ninths. And so our fraction turns into something you don't guess. People don't guess these things. Right, what was it, negative 5 ninths? And what was my last one? What, 5 ninths? Oh, that's kind of cool. Method of partial fractions. Kind of crazy that we can do that. So we will put that to good use and push it forward on Friday. So if you're done, of which there are 3 people with the web work, feel free to leave. The rest of us are going to stay here and work on web work. Unless we didn't bring our laptop, maybe. Is that the case?
That's the case.
Okay.
Might be a little irresponsible, but you know, I own a laptop for my last semester.
What?
Yeah, I just got this, like, for all 4 of my classes.
Oh, okay. We're gonna be doing a lot of that kind of work in here, so I don't know what
I'll figure it
makes
out.
me- Okay, all right, yeah. So, anybody need consultations?
On the web
Yes, Scotty, another write down there, yes.
Yeah, it definitely, have it written.
This one,
Sorry.
They have to, it's like.
Thanks, man.
Yeah, that looks. Oh, this one, yes, can I talk about this one?
Five.
Yeah.
That was the only one I couldn't do.
Let's talk about number
I
5.
saw question 5 and I was like, I'll just do that on Wednesday. I'll figure it out.
That's good. It was in there for someone to ask about, so
Yeah.
thank you. Yeah, I told you, that's what I do, that's my way. So sometimes you'll come across a problem and go, I know why he put that in. So Scotty, this surely was one that we wanted to talk to Dan.
Absolutely. There was, I hope it's this, not this one. Okay. There was one, did all my work on a whiteboard, never erased it without taking a picture of it.
Oh, that's not good.
Yeah.
I can't help you with that problem.
I know, that's my problem.
All right, and let's just make up some shit, so.
I'm gonna try that one.
So I'm making my values truly terrible. I don't know if they're any more terrible than what you got here, Sophie. So you're welcome. Okay, so.
Positive or negative 7?
Yeah, good question. Positive 7. All right, oh, and dx. So integration by parts allows me to integrate a part of the inside, right? So we usually pick like a U part that we're gonna differentiate, but we also pick a dv part that we're gonna take the antiderivative of. So for this one, we're gonna let u equal x, and dv is f double prime of x. And this is gonna allow us to start bootstrapping our way up out of that deep derivative. So we've got du is 1 dx. What's v? F prime of x, exactly. It's just one less level. So let's go to the uv minus integral v du formula. So that's going to become x f prime of x. And remember, we're evaluating that from 0 to 1. That's why they told me what f prime of 1 is. So now I've literally got the values I need. See, when I put in 1, I get 1, f prime of 1. Aha, that's 7. F prime of 0 doesn't matter because it's times 0. So it's kind of cool how that works out. We would need more information if we didn't have that 0. And then we put minus integral v to u. Do you see how to finish this up? What's the last step?
Then you do derivative, or antiderivative, which is f of x.
Yeah, beautiful. So then this just becomes f of x from 0 to 1. So this is 1, f prime of 1 minus 0, f prime at 0, minus, just like Sophie said, f of x from 0 to 1. And I actually do know both those values as well. So I can rock that out. So, yeah, let me come down here, Scotty. Jake. Yeah, so you want to finish this one first, and then, okay. Yeah, one thing at a time. Yeah. Okay. Let's get this. Yeah, how'd you get the 2 here? Oh, okay, got it. So can you write a little slower here? Write that out for me in notation underneath. Let's see what that looks like. And I'm gonna recommend in general doing that. There you go. Look at that, writing shit out. Imagine. Keep writing. Keep writing. Slowly. You just get it. You got it all done. Awesome. Yeah, I knew you were close.
Pretty good.
Yeah.
Just starting it. Haven't looked at it yet, but I can do it.
Yeah, absolutely.
And then once we're done with that, we're good to go.
Yeah, you can split.
You know when the next Webwork will be out?
Not till Friday.
Okay.
Yeah, so you got a little break, little reprieve from Calc for a couple of days. Okay, cool. You're always doing good. Yeah. So, yes. Let's see how you place it. Yeah. So this bottom part, let's look at that form really quick. So, so the derivative, arctan of u is 1 over 1 plus u squared times the u prime. The derivative, the inside. So what is your u?
So my u is 4y.
Yeah, so you got 4y. So do you see what's missing in yours? I put. Maybe? Oh, I didn't put 4 in front. And also, where else not? Look at the u. So your u is 4y. Look at the form. Where else does the u occur? So you've got the 4, that's the u prime. What is it you're not?
Oh, so that's 4y squared in the denominator. Okay.
That's it.
That makes more sense.
There you go.
Thank you.
You're welcome. Yeah, cool.
I had these two mixed up.
All right, good. I'm gonna encourage you to write more. Jade, how's it going?
I think I learned that, but, so, I was struggling with 2, 3, and then, oh, I didn't even know what to do with that. I was
So,
confused.
so some of them are integration by parts, others are not. This is a not.
Mhm. So, do I let, cause I was confused on what to let
Okay.
U be.
All right, so let's think about this. So you see an e in there, e to something.
Mm-hmm.
What does the basic e integral form look like? Let's write it out together. So it's integral of e to the u du Oh, you're thinking of the fancy version, so this, so I'm thinking of, oh,
Um,
sorry. So I'm thinking of, so let's talk about what you just said there. So I'm thinking of the more basic, like, this is the all-purpose form.
Oh, okay.
That's the form you wanna use here.
Mhm.
The form you're thinking of is a special case of that, where there's actually just a multiple of x inside there. So that's a good one, glad you're thinking of that. But that's a special case, just like if there's e to the 7x or something. But you've got, what would fall into the u? If I laid this over that problem, what would it say u had to be?
On this one,
Mhm.
x squared.
Yeah, then what's du?
Du is 2x dx.
Yeah. Are you seeing an x floating around in there also?
Uh-huh,
Hmm,
okay.
yeah. Does that make sense, that thought process?
Yeah.
Well, that's the key thing. Yes.
Had problems with the same exact one, but I thought I did everything well.
You did everything well except take the derivative well. So your u is great. What's the derivative of u?
5.
Yeah.
Yeah.
Yeah. I keep losing my tea. Does anyone see my tea around?
Oh, it's right.
Oh my God, thanks.
It saves five.
Rocking it. Awesome. All right. Yeah, have a good, see you on Friday.
Yeah,
Good whatever till Friday. Yeah. Awesome. Your sweater's really cool.
Oh, thanks. I got it in Mexico.
Oh, wow. It's not a sweater, I guess, really.
Drug rug, is what I call it.
That's what we called it back in the day, too. Because like at the Dead shows, people would lay their glasswares out on.
Of course.
Yeah, yeah.
Which one did you use as well?
I can't wait to tell my wife that, because that's where, yeah, she loves that term. Did it come together? Not quite.
All right, let's take a look. So let's see.
So, okay. Let's see, so we did, okay, so, yeah, so we let u be for y. We got d was, yeah, beautiful. So then you did, u v, so it's y art, yeah, cool, love that. And minus u, so you get the y on top, beautiful. Yeah, you're thinking right. Yeah, that constant out front definitely isn't right though, so let's see. So what happened to that 8? This is all beautiful right here, but where'd that 8 go?
So since it's this, that we can.
Oh, I see,
find,
I see, I
would
see.
make
Oh,
sense
I
to
see.
Take that out.
Oh, okay. Yeah.
Two.
Okay, gotcha. That makes total sense. Yeah, yeah. So I guess we had the 4 statement. Okay, so that's, yeah, that all seems totally kosher. Now I see exactly what you're doing. And it was a bonus, yeah. So gosh, it didn't like that, huh? Huh. Let me start from first principles again. So we got this, we got the 6 up front. And did you hit this with the 6 too?
Yeah, so I tried both, just the parentheses, and it's six.
Yeah.
Six.
We've got plus C for you.
I don't know if it lights the absolute value, I feel like it should.
It should absolutely be ecstatic about that, so, okay, so you, yes, yes. So then you is that. Huh, okay. May I use your pencil really quick? Thank you, I just, like, I need to write, to like do this, so we're gonna have, screw the 6. The 6 will come back to at the end, minus integral of squared dy. And yeah, I mean, like, it was man, I don't know. I like your answer. Let me look and see what they want for the answer. Okay, let's take a look. Sometimes that can help. I don't know what we could possibly be doing wrong there. What problem is that?
That's problem 3 for me.
Thank you. Oh gosh, dang it. Okay, let me look specifically at yours, because like, I just looked at a random one and totally is what we're doing. Guess you put a good effort in on that. Oh shit. Okay, yeah, no, okay, you're gonna really like it. So, this thing in the bottom is not 4y squared, it's 16y squared. Because it's 4y quantity squared, so it's
Gotcha.
16y squared, so it's like it. So this becomes 16, and then we're dividing by 16, not
8, so that would be 1 over 4
Yeah,
instead.
try that.
That should be.
Yes. So, okay, let's slow down this here. So, yeah, because we were getting the 8 before. Oh no! We get more smaller. This is actually 32.
Oh my goodness.
Right? Yeah. It's another 2. Another factor of 2.
There it goes. Okay.
Together we can do it. Sorry.
No, this is an integral by parts, right?
It is, or you can look it up in the table.
I was
So-
trying to do the table, but.
Oh, no, not that table,
Okay.
like the like integral table.
Oh, is there a thing that I
Yeah,
don't recognize?
otherwise you have to do this by parts twice, and we did this on Monday.
That's why it's not.
That's why it's not familiar, yeah. So, do you have that table?
Somewhere, I think actually I pulled up this.
Yeah, the old graphical sheet, so let's look at this together.
I was thinking both of them don't get any simpler, so I don't know which one to choose for you.
Yeah, so it's like a trick that's kind of cool. You should check out the video because it's really neat. But you don't have to like do it. I don't see any point in you doing it. So I think it's formula 98 or 99 actually.
See these two?
Yes.
So you just have to identify what A and B are.
That's where I'm confused.
That's not too bad, right?
What is the
Yeah.
Of course, should have known it was something like
I'm
that.
glad you asked.
Thank you.
I was going, I haven't even calculated how this one put it in like that.
Do you need consultation?
Yes.
Maybe.
Cause I was probably confused that. So for this one, so
Sorry,
like,
which one?
Yes, yeah.
so,
You found them in here? Cool. So, yeah,
yeah,
good.
okay, so when I do that, I get, when you pull up the four, like before, cause I have a four there. But I watched the video and I tried doing it
Cool.
after and it just wasn't working.
Alright, let me come around that. We're gonna have to get in here a little deeper. Alright.
So like, when you pull up the four,
Yeah.
does it go to both
Both.
of these? Okay.
So that's part of
let
our
me-
problem for sure.
Yeah, okay.
Let me try that.
Okay, cool.
Maybe
Professor,
Yes.
question.
Yes, sir.
So I'm doing this one right now,
Mm-hmm.
and I integrated by parts. I'm just not sure where I went wrong.
So you need to do it twice?
Yeah.
Yeah, and
I
you
did
did
it.
it, okay,
This
cool.
is the second
Alright,
time
let's
down
take a
here.
look. So we got, keep the 64 out in front. Did you bring the 64 back in at the end?
I have a second page.
Oh, okay, cool, okay, got it, okay, cool. So just check, I was
Yeah.
hoping for like an easy,
Yeah, no worries.
easy answer. See how fast. Okay, so, yep, this is all beautiful. So then we want.
I got it.
You, woohoo! That was it?
Yep.
Oh, that's awesome. Good job.
I,
So-
well, so I followed the
Yeah,
rules,
so this all looks
if
good.
you see on the sheet. I was doing that, but I
Could pull
pulled
that out,
the
make that a
form
1/2,
before, 'cause mine had
also
a
cool,
forward
right?
Oh.
Like, so,
before, so I
Yeah.
pulled
but
it
that's
out.
okay.
I forgot to
But
distribute
sometimes
the form,
carrying
so I
around these
just
things
had it
can
on this
make-
rough part,
make it
on
confusing.
the-
yeah, or
this
just
part,
like
and on
promote
this one,
errors,
so-
potential errors.
Okay,
So we've got
that's good.
U is 2x again, so 1, 2. And I got a feeling that's probably what happened in the end, like the net effect of all these numbers is
Maybe,
gonna
yeah.
create
Because
misery
go to
for
the
you.
sheet, you have the
So let's see,
sheet,
so dv is
like this
that,
thing,
and
here,
then
I'll just show you.
v
So it's on
is
low class, so this
negative, yep,
is
beautiful.
what that is.
So,
Oh yeah, so you pull, what I did is so, just in
okay, where is this?
But I pulled out the
And then
form,
That's
and
this
then
here.
this
Yeah, I
is
integrated by
Okay.
this.
parts. if you
Okay,
will.
I see, and then you brought
And
the
then
coordinate,
that's
okay,
this one.
okay.
So then
Did you
your
bring the
derivative or your
minus
integral
across?
is-
Yeah, I did that on the next page.
Okay,
Yeah.
okay.
So,
Oh, lordy.
so this one is
Yeah.
this, so I distributed negative,
Yeah.
made that a positive, and then this one became a negative.
Okay, so let me check, okay. So we did UV minus integral.
No, I was getting lost.
So this becomes another integral.
Like,
Yeah, I think
Okay.
I just didn't put the.
Okay, I'm gonna put it here, okay?
Okay, yeah, no
I was
worries.
doing stuff like that.
Cause it needs to be there, so integral
God, you just gave
V,
me a heart attack with that. I thought we had a survey. We don't, right?
beautiful, okay. So,
I think maybe that's actually
the problem,
I didn't.
you didn't
maybe I-
actually do one more
maybe I didn't
integration, I
integrate
don't
it.
see it in there.
Yeah, I did not.
Yeah,
I
that's
did
your
not
problem.
integrate it. Okay.
So,
Cool.
my recommendation to you, same thing, I was recommended to our friend Scotty, more notation.
Yeah,
Just
so
to be
to
safe,
follow.
just yeah, a little more precise, a little more detail, and then it saves this.
Yeah, no,
Yeah.
for sure.
It's like a little pay up front, but.
Yep.
Yeah, they're all like that. It's a 80.
Woohoo! Is that it, your last one?
That was.
Outstanding. recording because everything we're doing is local.